Hello guys, welcome to our class for today. We are still looking at vectors, but at this time around we're going to be looking at resolution of vectors or resolution of two or more vectors acting at a point. Resolution of two or more vectors acting at a point. So this is Normal Math Science Tutors Online. We are bringing physics direct to your very doorstep. So please, if you have not subscribed to our channel, please subscribe to this channel. Click on the notification button so that when we upload a new video, YouTube will notify you. Also give us a like, give us a thumbs up if you like what we're doing. You can reach us through the WhatsApp number that is showing on your screen. So for us to go to the class, please get your writing materials. We also encourage you to invite your friends or talk about this channel to your friends so that they can come and join and also enjoy the lectures that you are enjoying. So get your writing materials and let's get settled so that we can go to the class for today. Resolution of two or more vectors acting at a point. Okay, for our class today, we are going to be looking at resultant of two or more vectors acting at a point. So if you have a situation like this where you have two or more vectors acting at point O, this is assuming this is point O, right? Assuming this is point O, and you have two or more vectors acting at this point, how do you go about solving it? Now, what you do is that what you will do in this case is that you are going to resolve all the forces that are acting at this point into the y component and then the s component of the forces. Then you are going to resolve them into cosine. You resolve them into the cosine using the cosine and the resolve them into the x and the y component. Yes, resolve all the forces to the x and the y component. Okay, so the s component of these forces acting along this parallel line, acting on this line x axis, you resolve them into this x and y component. So how you will do them is what I've summarized down below, right? So you take cognizance of the horizontal component for each of the forces and the vertical component of each of the forces. So when you look at the forces F1, F2, F3 and F4, the horizontal component of each of them, the horizontal component of each of them, F1 is F1 cos theta, F2 cos theta, then F3 is minus F3 cos theta, and F4 is minus F4 cos theta. Then the vertical component of each of these forces, you have F1 sin theta, F2 sin theta, F2 minus sin theta, F4 sin theta, and F3 minus sin theta. So after you have gotten their components of the horizontal and vertical component, you add up the components separately. Add up all the s components of the forces, add up all the horizontal, all the y component of the forces, so that you will now have a diagram that gives you the s component and the horizontal component. From there, you can now find the resultant of all these forces that are acting at a point. Is that okay? So at the end of the day, you are going to have two forces, x and y. Then you can get the resultant of the two forces acting at this point. So this is just how to solve it. So right away I will solve a problem now so that I can drive on this point. Is that okay? I will solve a problem now to drive on that point. I also want to know that if a vector is actually a line of the axis, that if a vector is on this particular axis, right, then the angle of inclination of the vector, if it is on this axis, it is 0 degree. If it is on the vertical axis, it is 90 degrees. So if you have a vector that is on this line, the angle of the vector will be 0 degree. If it is on this line, the angle will be 90 degrees. So depending on the alignment or the angle of inclination of that particular vector. So this is a question so that you can drive home this point easily. Calculate the resultant of 5 coplanar forces of values 10 Newton, 12 Newton, 6 Newton, 16 Newton, 20 Newton, 15 Newton acting on an object at O as shown below. Right, so if you look at this particular question, you see that the force 10 Newton is acting on the horizontal x-axis, while the force 16 Newton is acting on the vertical y-axis. So which means that the angle of inclination of this 10 Newton is 0, while that of this 16 Newton is 90 degrees. That's what we discussed before. Okay, so having that said, we are going to take the vertical component and the horizontal component. Okay, so that is what you do. First of all, you are going to take the vertical component, or say, okay, this is now say S component, which is the horizontal component. You write them down, component. Then you have the Y component, which is the vertical component or the forces. So for the 10 Newton force, the S component for that one will be 10 cos 0, right? It will be 10 cos 0, and cos 0 is equals to 1. So 1 times 10 will give you 10. Okay, then for the 12 Newton force, you have 12 cos and 50. 12 cos 50. So if you work that out, cos 50 multiplied by 12, you are going to have 7.71. Please work that out. Find cos 50 multiplied by 12 to give you 7.71. Then for the 15 Newton force, same thing that you would do. 15 cos the angle of inclination. The angle of inclination for the 15 Newton force to the horizontal is 60 degrees, but they give you the one to vertical, so you find this angle. This is the angle that you need. So this angle is 60 degrees. 90 minus 30, so that is 15 cos 60. So 15 cos 60 will give you 7.50. Do that one out, you are going to have 7.50. Okay, then you have 16 degree acting vertically. The angle of inclination is 90 degrees. That's what we said before. So this is 16 cos 90, right? 16 cos 90 is 0, so this is 0. Then the last one there is minus 20 cos 40 degrees. So if you work that out, you are going to have minus 15.32. So after you've done all this, you add everything together. So this is for the S component. You now come to the Y component, the same thing that you did for the S component, but this time you are using your 10 sine 0. This gives you 0. Next one is 12 sine 50. 12 sine 50. This gives you 9.19. The other one is 15 degrees minus 15 sine 60 minus 15 sine 60. This gives you minus 12 points. That's minus 12 points. Online. Then the next one is minus 16 sine 90. Minus 16 sine 90. That gives you, sine 90 is 1, so that gives you minus 16.0. The last one is 20 sine 40. 20 sine 40. Okay, so 20 sine 40, if you work that out, you are going to have 12.85. 12.85. So after you are done that, add everything together. Right? If you add everything together, the S component of this force, this will give you 9.89, while the Y component is going to give you minus 6.95. This is plus 9.89, while the Y component is minus 6.95. So having gotten the S and the Y component, you can put them in the drawing. You can now represent them by the simple drawing. So you use this drawing to represent that, so you can get your resultant. This is your resultant. So you have your S component 9.89, then you have your Y component 6.95. 6.95. Okay, so this is what you have. So from this you can now find your resultant with this triangle. You can find your resultant using the Pythagoras theorem. So using the Pythagoras theorem, you're going to have r squared is equals to 9.89 squared plus 6.95 squared. Okay, so when you multiply that out, you are going to have this 97.81 plus 48.30. So, and when you add up this, you have 146.11. Okay, so your arrow, if you square both sides, you add that your arrow is equals to square root 146.11, and that gives your arrow to be equals to what? 12.098. Okay, so this is how to solve this. Then if you want to find the angle of the resultant, you can use the trigonometric ratio tangent. Tangent is opposite over adjacent, so you can say tan theta is equals to what? Y over x. You have already gotten y over s to be, y is 6.95, s is 9.89, so that will be 6.95 all over 9.89. So when you do that division, you have 0.700 0.027. So your theta is inverse tangent. Your theta now, which is the angle, is equals to inverse of tan. Inverse of tan 0.7027. So when you solve that out with your calculator, you are going to have 35.1 degrees. 35.1 degrees. That's okay. So this is angle theta. So your angle theta is equals to 35.1 degrees. So this is how to solve any problem that looks like this. Say you have more than two forces acting at a point. This is how to solve them. First, find the x component, the y component, do your addition, and then use your Pythagoras theorem and you get your answer. That's okay. So I hope this is relatively simple. This is relatively simple. If you have any question, you can put it on the comment section. That's okay. If you have any question, put it on the comment section, or you can reach me through the WhatsApp number that is showing on your screen. So this is a question for you to solve. This is test your understanding. Solve this question. You can snap your procedure and your answer and send it to the WhatsApp number. I will look at it and then make my own comments. That okay? So this is where we are ending our class for today. Thank you so much. Please guys, if you have not subscribed to our channel, please subscribe to our channel. This is Normal Mind Science Tutors Online. We are bringing physics direct to your very doorstep. So if you like what we are doing, give us a thumbs up, give us a like, give us a positive comment, subscribe to this channel if you have not subscribed, invite your friends so that they can also come and enjoy this physics class that you are enjoying on YouTube online. Reach us through the WhatsApp number that is showing on your screen. Right, so thank you for your time and we'll see you in our next class.